Yes, I believe you have solved. Try this exercise on your own. If you probably solved it here, you're just here for the confirmation. So let's solve together. We're using SOHCAHTOA. Sine theta is equals to opposite over hypotenuse. Cos theta is equals to adjacent over hypotenuse. And tan theta is equals to opposite over adjacent. So let's begin with question 1. We have triangle ABC, A, B, and C. Right angle at B with AB to be 3 centimeters. Angle ACB is 61 degrees. And we are looking for angle CB. Let's call it X. Now, in this case, the side facing the angle is also the opposite. It's known as the opposite. So 3 centimeters is the opposite. We are looking for the adjacent X, and we have an angle. Let's call it theta to be 61 degrees. Now the question is, which expression relates the opposite and adjacent together? This is opposite and hypotenuse. This is adjacent and hypotenuse, but this is opposite and adjacent. So we are going to be using tan theta is equals to opposite over adjacent. Therefore, we will make our substitution. Tan 61 degrees is equals to opposite, which is 3. The adjacent we are looking for is X. So making X to formula, we can say that our X will be equals to 3 divided by tan 61 degrees. An expression for tan 61 is simply 1.8040, and the final answer for X will be 1.6630 centimeters. So that's that. Question number 2. We have the diagram 13 to be the hypotenuse and angle 50 degrees. We have 13 to be the hypotenuse, angle 50 degrees. Is a right angle triangle, and we are looking for X. X. Now, in this case, the side facing the angle is known as the opposite. Okay, so we are looking for the opposite, which is X. We have the hypotenuse, which is 13, and angle theta, which is 50 degrees. Now, we want to look for the expression that relates opposite and hypotenuse together. Going from tan theta, this is opposite and adjacent. This is adjacent and hypotenuse, but this is opposite and hypotenuse. So we'll be using sine theta. Sine theta is equals to opposite divided by hypotenuse. So with that, we make our substitution. So this is sine 50 degrees. And this will be the opposite, which is what we're looking for, X, divided by the adjacent hypotenuse, which is 13. So making X to formula, this will give us 13 multiplied by sine 50 degrees. What is sine 50 degrees? Sine 50 degrees is equal to 0.7660. Multiplying it by 13, we will have the result of 9.9586. Doesn't have a unit. And finally, let's go to question number 3. We have this. A right angle triangle with a hypotenuse of 7. The angle here is 45 degrees, and we are asked to evaluate y. Y, is it the opposite or the adjacent? Since the angle facing this is the opposite, the side facing the angle is the opposite, definitely y is what? The adjacent. So we are looking for adjacent y. So that means we have adjacent is equals to y, hypotenuse is equals to 7, angle theta is equals to 45 degrees. So we are looking for the relation between adjacent and hypotenuse. If you see, sin theta is opposite over hypotenuse. Cos theta, however, is adjacent over hypotenuse. So that's what we'll be using. Cos theta is adjacent divided by the hypotenuse. Therefore, making our substitution, we will have cos 45 degrees is equals to adjacent, which is y, divided by the hypotenuse, which is 7. Simplifying further, making y is to formula, you can see that y is equals to 7 multiplied by cos 45 degrees. Cos 45 degrees is equal to 0.7071. Multiplying this result by 7, we will have our y to give us 4.9497. So we have solved the exercise. The whole duty of the exercise is to show that we can relate sine theta as opposite over hypotenuse, cos theta as adjacent over hypotenuse, and tan theta as opposite over adjacent in a right angled triangle.